Hi. Three things break in a naive AI agent. The context window blows up, the model gives meta answers instead of real answers, and it forgets everything between the sessions. Today, I'll show you PMDA, memory, perception, decision, action, the architecture that fixes all these three. So, for target queries, I'll be executing, and all of it would pass. So, just to give a little background, previously our naive agent, agent 5.py, used to put every tool result straight into the message list. One Wikipedia fetch is 34 kilobytes that blows past 8K tokens limit instantaneously. There's no goal tracking. The model says, how would you like to proceed instead of actually doing that work. And between the sessions, there's no memory, so it doesn't remember anything. So let me quickly dive into the demo. So I'll be carrying out four demos. So here in this terminal, by the way, I'm using LLM Gateway, where all my calls would be routed via a cluster of LLMs that I am connected to via API. So here, back to the demo, let me run this. And for the sake of the demo, I have also saved the previous run here. So the query here is to fetch this URL and tell me his birth date, that date, and three key contributions to the information theory. So what's this iteration one? So decision calls fetch URL, uh, and the Wikipedia returns the 34 kilobytes of data. So rather than dumping that into the context, action stores it as an artifact. So you'll find the artifact here. So these are the artifacts. So a content addressable blob on the disk, if it's below, I think, 4 kilobytes, then it after above 4 kilobytes, it would store as a binary file, and a reference of that file with a bit of metadata is stored in the JSON. So in the iteration two, so yeah, this is the output of it. Let me show it a bit better. So the iteration two, the perception sees the fetch is done and attaches the artifact to the extraction goal. So the decision reads the full 34 KB page and returns three facts as a plain text, no extra tool call. So the four iterations actually pass, which is still going on here. And yeah, so the scenario B, so if you see here within the four iterations, it has passed. I think, yeah. And the scenario B, similarly, you see the terminal output here. I have put it here as this scenario B is to find three family-friendly things to do in Tokyo this weekend. Check Saturday's weather forecast there and tell me which one is appropriate. So that's when I give this query B, the same query is issued. And similarly, perception creates three separate goals. So find activities, check weather, and recommend. So decision searches twice, fetches the weather page, and synthesizes a recommendation. So in all together, there is like 9 iterations. So yeah, if you see here, yeah, it's the same terminal output I'm put here for better viewing purpose. And then the so next scenario is a twofold scenario. It's to represent the durable memory. This is the most important test. So this is the C1 query where we give the mom's birthday and ask it to book a calendar, remember that in a calendar and set a reminder. And once that is done as a follow-up query, we give this when we ask when is mom's birthday. So this is to test that this 15th May 2026 is fetched. I'll later show you in the memory.json as well how it is saved. So here as well, so in the scenario C, Um, yeah, let me go through from the top here. So if I give C1, this query is taken and it goes through several iterations. And so in C1, it makes sure that the memory has saved that uh, persisted the date of birth, and it yep, it says that it has done all these. Then similarly in the C2, so if you see here, there's a C2, then a follow-up query is issued. Then it goes through its memory. In the first iteration itself, it has found, but then it again goes through few more iterations before giving a final answer. So it's the same here. If you see, it's used iterations used is four, and it says passed, and the same. And similarly, the final scenario, the D. So search for Python async IO best practices. Read the top three results and give me a short numbered list. This is the one, the scenario four. And if you see here, the scenario, whatever is here, I'm showing again here. So the query explicitly asks to read the top three results. Perceptions create five goals. Search, fetch first, fetch second, fetch third, synthesize. And each fetch goal gets the search results artifact attached. So the decision knows exactly which URL to call. So, so I think, yeah, the third tool here, it is not able to access it. So it gives a 403 a forbidden error because it's unavailable. But on the whole, it synthesizes it. And in, I think, 12 iterations, it is able to give you the final answer of what the search result is about async IO. Okay, just quickly going back to the yeah, this is the memory.json, and as I said, here is where as I said, the birthday is stored for the C2 in this memory. Uh, and back to the architecture, this is the PMDA that I was talking about. So the memory uses a keyword-based retrieval, persistent JSON, LLM classification. The perception does a LLM goal tracker, sticky style done in Python, artifact index resolution. Then the decision is for native tool use. Tools are like MCP tools, tool choice, etc., and some rules. And then action is pure MCP dispatch. Um, the 4096 KB, the 4 KB threshold is also governed here. So the max is loop, max it runs us for 15 iterations as per the ask here. For the scenario A, we were asked if it can be done by six scenarios. We have done it in four. Similarly, all the others are well within the expected iterations. Uh, yep. So the code, the logs, everything is available here in the README file and in my GitHub. Thank you. Good day. Bye.